This video is for Math 150, Emily Ploch, Chapter 10, Section 2, question number 15. Okay, so the question is, in a clinical trial, 29 out of 800 patients taking a prescription drug complained of flu-like symptoms. Suppose that it is known that 2.4% of patients taking competitive drugs complain of flu-like symptoms. Is there sufficient evidence to conclude that more than 2.4% of this drug's users experience flu-like symptom as a side effect at the significance level of 0.05? So they're going to ask you what the null and alternative hypothesis is first. So the null hypothesis is always that it's going to be equal. So P, because we're looking at percentages, so P is going to be equal to 0.04, which is the known average percentage. And then the alternative hypothesis is going to be that P is greater than 2.04, because in our trial in our one trial we got a higher percentage. So we're seeing if like our drug has a higher percentage, or if just maybe that one sample had a higher percentage, and what the likelihood of that is. So we're going to use technology to find the p-value. I use the equation first. So the equation is z, so is going to be equal to p hat minus the null hypothesis p over the square root of null hypothesis p times 1 minus null hypothesis p all over n. P hat is going to be equal to your samples x over n, which is 29 out of 800, which puts you at 0.03625. P of null hypothesis, as stated above, is 0.024, and n is 800 because we had 800 patients. And then, so you're going to plug that into the equation, and it starts to break down until you get the answer, which is z of null hypothesis is 2.2639. So now that you have your z value, you can use that to find your p-value. So since this is percentages, you're going to be using a normal distribution. So what we're going to do is find the likelihood that it is greater. So we have normal CDF, and then your lower portion is, their lowest number is 2.2639, and your highest is just 5 nines, just a really high number. And then since we're using a a normal distribution, it's going to be 0 and 1, 0 for the mean and 1 for the standard deviation, and then that comes out to 0.01179. So the likelihood of this happening is 0.0119. 0.0119 is less than the level of significance, which is 0.05. So this is a significant enough difference at a 0.05 significance to assume that this isn't just this one trial that that caused us to have a higher percentage. It's probably the drug itself causes the higher percentage than the other competing drugs. So we put the p-value up here, which we got, which is when you round it 3 decimal places, you get 0.012. And then we're going to, since the p-value is less than alpha, we're going to reject the null hypothesis. So we're going to reject that p is equal to 0.024, and conclude that there is sufficient evidence that more than 2.4% of users experience flu-like symptoms.